Hi guys, this is our second of 3 examples of solving systems of equation by substitution. So again, according to the directions, we cannot solve this system however we like. We have to solve by substitution. So to recap, how do we solve a system by substitution? One, we're gonna pick an equation and then solve for any variable. And then two, we're gonna substitute that expression into the other equation we didn't use. So ideally, it would be nice if we had a variable whose coefficient is 1 or -1. In this case, we do, and if we didn't, then we'll work with it. Okay. So let's go ahead and speak to ourselves. So we're gonna go ahead look at the second equation and solve for x. So the second equation reads x plus 3y equals 2, and in this case we decided to solve for x. Okay, so that will leave you with x equals whatever your heart desires. We are not graphing, and if we did, this is not solved for y, so I'm not even thinking slope-intercept form. For me, it's just easier to start on a positive note, but if you want to put -3y then the +2, go for it. Substitution, how does that work? Pick an equation and solve for a variable. And then two, we're going to substitute this expression into the other equation we didn't use. So let's go ahead, plug it into the first one. So again, I love speaking to myself. So sub into the one we didn't use, which was equation 1. So that will give us 2x plus 6y equals 4. And we have a nifty expression for x. So wherever we see an x, we are going to replace it with the expression given by 2 minus 3y. Why? Because we have x equals this. So we have 2 times expression for x, which is 2 minus 3y. And then at this point, I feel like I got this because again, all the equations before this step had 2 variables. But once we do the substitution, we're only going to have 1 variable left. So at this point, let's solve for that 1 variable that we see. So we'll distribute the 2, and that will leave us with 4 minus 6y plus 6y equals 4. You take your time, combine the like terms. The sum of -6y and +6y will give us 0, or we say it cancels, and that will give us with 4 equals 4. Now, from the previous video, you know what place I'm gonna put. Like, I thought I was like the hotness when it comes to math, but then I see 4 equals 4, and I'm like, what's going on? That's a little bit weird. So what do we do? Should we subtract 4 from both sides? I mean, you could, but we were not trying to solve for 4. We were trying to solve for y. So remember, if the variables cancel out, I need you to stop right here and ask yourself, do I have a true or false statement? Okay, so last time I checked, 4 equals 4. So unfortunately, this is a true statement, and I say unfortunately because if it was a false statement, then we tell the readers that the system has no solution. But if the variables are out, if the variables cancel out and we're left with the true statement, then this means that the system has an infinite number of solutions. So infinite number of solutions. So I use my made-up abbreviations because I'm not gonna submit this for credit. I'm just speaking to myself. So in this case, the solution should be of these ordered pair solutions. But the question is, how do we write the answer? It's not feasible to write like a long list of solutions. We have infinitely many ordered pair solutions. So in this case, we are gonna have to introduce a parameter. So let me go ahead and speak to myself. Introduce a parameter. When do we have to introduce a parameter? We're going to do this when the system has an infinite number of solutions. So a parameter is just pretty much a new variable that can take any value. Okay, so we're going to introduce any variable of our liking, anyone with the exception of x or y. I don't see u a lot, so whenever we do some substitution, we're gonna usually use u, but you can use a for all I care. Okay, so we're gonna introduce a parameter, which is again, a parameter is just code for a new variable that can take any value. And in this case, we're gonna write both x and y in terms of the variable u. So the question is, should we say let x equal u or let y equal u? You know what? It really doesn't matter. the expressions will look different, but it's okay. There's more than one way to write it. Okay, so unless the book can read our mind, the book answer may look a little bit different than our answer. So this is how I do it. So I'm gonna take any equation and solve for x or y, but we already have an equation that's solved for x or y, so I'm gonna take it. I'm gonna start from here. So again, you know I love speaking to myself. So from this bad boy, so again, you take any equation and solve for x or y. And then the question is, should I let x equal u or y equal u? Because remember, when we introduce a parameter, we want to write both x and y in terms of this variable. And again, it doesn't matter if you say let x equal u or y equal u. What I want to point out is this. From this equation, we already have something that's solved for x. So what I recommend is that you let the other guy represent u. So we're going to say let y equal u. Okay. So again, we wanted to write expressions in terms of this parameter u. We already have something for y. Y equals u. Now we need to work on getting an expression for x in terms of u. So let's go ahead, substitute y with our new variable u, or with the parameter, same difference. So that will give us x equals 2 minus 3 times y, which we're saying is u. Okay, we had an expression for y. Let me go ahead, highlight that in terms of u. Thanks to our hard work, we have an expression for x in terms of u. Okay, so in this case, we want to write the solution as x, where my x is 2 minus 3u, y, which is u. Okay, but this only looks like one ordered pair, so we're going to have to write this in set builder notation. So new to your life, what is the solution set? The solution set is given by these bad boys. So the set of ordered pairs 2 minus 3u, comma u, such that, but we don't have time to write the word such that, so we're going to write a vertical bar, so that is read as such that. Such that what? Such that what's so special about this letter u? Such that u is any real number. Is any, I'm out of space, so if there's no space, then you make space. Such that u is any real number. Okay, let's go ahead, close the brace. Okay, so the question is, when do you have to introduce a parameter? You introduce a parameter when you realize that the system has an infinite number of solutions. Whatever variable you use, doesn't matter as long as it's not x or y. It doesn't matter. Whatever variable you use, you're going to have to write both x and y in terms of your parameter, or that new variable that you selected, and then make sure to write the answer in set builder notation. So in set builder notation, the solution set is given by the set of ordered pairs 2 minus 3u, comma u, such that u is any real number. So that's pretty much it. But in order for you to have a sense what this means, we are telling the reader that all the solutions have to take this form. So like say, for example, so if u equals 1, what would that solution look like? So again, our solutions are given by ordered pairs of the form 2 minus 3u, comma u. So if u is 1, so we have 2 times 3 times 1, comma 1. So that will give us 2 minus 3, or negative 1, 1. Okay, so we are telling the reader that negative 1, 1 is a solution, and then we're not going to list more because this will be a never-ending story. But again, you don't have to show some solutions, just write the actual solution set. When the system has an infinite number of solutions, introduce your parameter, again, a new variable that can take any value. Write both x and y in terms of your parameter. Once you have x and y in terms of that parameter, then go ahead, write your answer in set builder notation. Thanks, guys.